Make a statement about a transverse pulse, relating the motion of each separate coil of the slinky to the direction of propagation of the pulse. Um, the transversal pulse was to the side at different intervals, so we got to study all the different wavelengths, how to make them, and the intervals and the amplitude of each wavelength. How does the shape of the pulse appear to change as it travels along the slinky? Give a reason for the change. Well, the shape of the pulse changes because it's losing energy as it goes along. So, uh, it change. So when I would shake the slinky, as the the waves would go through the slinky, it sometimes it'd start out and end the same, but if I didn't uh shake it hard enough, it would die down. Does the speed of the pulse appear to change with the shape of the pulse? Uh yeah, I think so. The speed was a big factor of the shape of each pulse. So it depended on how hard or how soft I did it. So if I did it really soft, then if I shook it softly, my wavelengths would be really big, and I wouldn't have as many. I just have some waves. But if I did it really fast, my waves would be really tiny, and I'd have a lot of them going at once. Um, Make a statement about a longitudinal pulse, relating the motion of each separate coil of the slinky to the direction of propagation of the pulse. The longitudinal pulse was different because the slinky didn't have enough physical space to make as big of a wave as a transversal. So because of because of that, the wavelength of it was a lot smaller, and it was uh it was less as drastic, so the waves weren't as big as the other ones. What is the difference between the observed transverse pulse and longitudinal pulse as it relates to the motion of each separate coil of the slinky? Uh, I think the difference was that the shape and speed of each wave affected the pulses. So, depending on how hard, depending on the strength I use to make my waves, really affected the pulse. And because the the speed and shape make up, so that is the pulse. Uh, upon what does the initial amplitude size of the pulse depend? Um, I think it depends on how rapidly I would move the slinky, and that the faster I shook it, uh, the the waves when I shook it fast, though the size of those waves predicted the shape of each of the pulses. Does the pulse speed appear to depend on the amplitude size of the pulse? Yeah, I think so. The faster the speed, the shorter the waves, but there were more than if I was to shake it more slowly. Um, was the wave speed different for the different frequencies? Yeah. I did different speeds to see all the different frequencies and like get a feel on how it actually works and stuff. Make a general statement contrasting the wavelengths at the different frequencies. Um, make a general statement contrasting the wavelengths. Uh, the faster we shook it, the more the waves appeared. So our results were really varied. My results were really varied. I did it with a friend, uh, and so some of my waves were a lot smaller. Uh, with a fast speed, but if I did it with like a slow speed, I got them to be uh, a lot bigger than than when I do it with a fast speed. As the distance between the ends of the slinky changed, the tension in the as the distance between the ends of the slinky changed, the tension in the slinky changed. What what effect did the distance between the ends of the slinky have on the transverse pulse? An example, did the pulses move faster or slower? Did they have bigger amplitudes? Yeah, the distance was a factor to the wave shape and its length. So the greater the distance, the smaller the amplitude. Or for me, it was a lot harder to make an amplitude. And the shorter the distance, the bigger the amplitude, which wasn't that hard for me to do. What did changing the distance, in example the tension, represent in terms of how waves travel? This represents that waves will be bigger and cover more area in short terms.